Hello and welcome to your end of semester mechanics of human movement revision, kind of, sort of. It would be if we were all in the university pub quiz, but nonetheless we will persevere. This is a multiple choice quiz, and if you're taking part, which I assume you are because you've started watching this video, you will need a pen and paper, you will need a calculator for some questions, and you will need a timer if you really want to play along. I typically allow 30 seconds per question. There are, I can't remember now, 18 in total, something like that. But I usually allow 30 seconds unless you're told otherwise, so I don't pause in between each question and just sit here in silence whilst you figure it out. I will move from each question, I will move from question to question basically, and you will need to pause the video and then set your timer and then carry on from there. We will obviously discuss all of the answers at the end and have a bit of a chat about them. But other than that, if you want to pause here and get everything you need, and we will begin rather logically with question 1, which is, he says, which of the following is not a component of biomechanics? Is it A, physics, B, anatomy, C, mechanics, or D, mathematics? So 30 seconds, pause here, and I will move on. Okay, moving on to the next question. Kinetics and kinematics refer to the study of what? Is it A, movement and forces, B, forces and time, C, time and forces, or D, forces and movement? Okay, moving on to question 3. Which of the following best describes the anatomical position of the rectus femoris muscle? Is it A, lateral to the vastus lateralis and medial to the vastus medialis, B, superior to the vastus lateralis and inferior to the vastus medialis, C, inferior to the vastus lateralis and superior to the vastus medialis, or D, medial to the vastus lateralis and lateral to the vastus medialis? Okay, moving on. In which plane of motion does the majority of movement occur when performing a lunge? So in which plane of motion does the majority of movement occur? Is it A, the coronal plane, B, the sagittal plane, C, the frontal plane, or D, the transverse plane? So again, the emphasis there on the majority of movement. Okay, you're going to need your calculator for the next 2 questions, and you have 60 seconds for the next 2 questions. So, you perform a vertical jump exerting a force of 2,347 newtons over a period of 0.9 seconds. What impulse is produced? I should perhaps read how much impulse is produced, but never mind. Is it A, 3002.8 newton seconds, B, 2607.8 newton seconds, C, 2507.8 newton seconds, or D, 2112.3 newton seconds? And again, that's 60 seconds for this one. Okay, moving on to the next question. You perform a vertical jump exerting a force of 2,374 newtons over a period of 0.9 seconds. How much momentum is produced? Is it A, 2,117.8 kilogram meters per second, B, 2,116.1 kilogram meters per second, C, 2,117 kilogram meters per second, or D, 2,112.3 kilogram meters per second? Okay, moving on to the next question. You don't need your calculator anymore, and we're moving back to the 30-second time limit if you're playing along properly, and you best be. Which of the following is the most accurate definition for inertia? Is it A, inertia is the force produced by an object's mass due to gravity? B, inertia and mass are synonymous, so they mean the same thing. C, inertia is an object's resistance to acceleration. D, inertia is an object's resistance to deceleration. Okay, moving on. Which of the following is not one of Newton's laws of motion? Is it A, the law of inertia, B, the law of acceleration, C, the law of gravity, D, the law of reaction? So which one is not one of Newton's laws of motion? Okay, moving on. Which of the following is the most accurate simplified definition for linear velocity? So a more sort of layman's term or layman's definition for velocity. A, velocity is the product of speed and direction. B, velocity is constant unless an external force is present. C, velocity is distance divided by time. D, velocity is synonymous with momentum, so they mean the same thing. Okay, moving on. Which of the following is the most accurate description of the work done when lifting and then lowering a barbell? Let's say you're doing a barbell curl. So you lift it and lower it. What sort of work is done? Is it A, positive work and then negative work? B, negative work and then positive work? C, active work and then reactive work? D, reactive work and then active work? Okay, let's move on. Which of the following is the most accurate definition for mechanical power? Is it A, power causes movement or deformation? B, power results in a change in an object's velocity? C, power is the product of all of the forces acting on an object? D, power is the amount of work done per unit of time. Okay, for the next question, you have 60 seconds. Place each of the following features of the gait cycle in the order in which they occur. Mid-swing, heel off, initial contact, flat foot, mid-stance, terminal swing. So you need to rearrange those from first to last in the standard gait cycle. Okay, for the next question you have 3 minutes. So that's 3 minutes. Which of the following equations are incorrect? Basically, just identify any of those equations that you think are not correct. I'm not going to read them all out because I'll be here for days. You can see them there, but some of them are right, some of them are wrong. Which ones are the incorrect ones? Okay, moving on, and we're now going back to a 30-second time limit. Which of the following is inaccurate? An unopposed force will cause A, an object to accelerate, B, an object to deform, C, an object to change its speed, D, an object to move. E, forgot there was an E, an object to change its velocity. So which one of those is inaccurate? There may be more than one, there may be several, but you have to complete the sentence. An unopposed force will cause what? As I say, maybe one, maybe several, who knows? I do, obviously. Okay, for the next question then, you will need a calculator once again, and you can give yourself 90 seconds for this one. So, the Achilles tendon inserts 5 centimeters from the ankle's axis, that's the axis of rotation. If one calf muscle produces 3,000 newtons of force, how much torque is produced when you stand on your tippy toes? Is it A, 150 newton meters, B, 120,000 newton meters, C, 6,000 newton meters, or D, 300 newton meters? Okay, so once you've finished this question, you won't need your calculator for the next one, and we're back to 30 seconds. You hold a barbell in a static position with your elbow flexed, that should read to 90 degrees. The barbell produces an external torque of minus 254 newton meters. What is the magnitude of internal torque required by the elbow flexors to maintain the barbell's position? You may wish to take some time to reread that. You hold a barbell in a static position with your elbow flexed at 90 degrees. The barbell produces an external torque of minus 254 newton meters. What is the magnitude, so how much internal torque is required by your elbow flexors, biceps brachii and so on, to maintain the elbow's position? Is it A, 254 newton meters, B, 228.6 newton meters, C, 852 newton meters, or D, it's a trick question because this is the last question, and in fact your elbow extensors would be required for this movement, not your flexors, so it's a trick question. So have 30 seconds and then we will talk through the answers, and you can pass your answers on to someone else, or just mark yourself. Okay, so moving on to the answers then. Question 1 was, which of the following is not a component of biomechanics? Your options were physics, anatomy, mechanics and mathematics, and the answer is physics. Biomechanics is made up of, as I've said before, it's a bit of a patchwork quilt of a subject. It's obviously going to have to use an element of anatomy to understand human movement, because we're applying biomechanics to sport and exercise science. So we need to know the anatomy of what it is we're applying this subject to. We borrow a branch of physics, i.e. mechanics, to assess human movement, but we don't use physics on a whole. Physics is a huge topic that has many sub-topics within it. Mechanics is one of them. We don't use quantum physics, for example, to understand human movement. So the answer is A, physics. That's the odd one out. Question 2 was, kinetics and kinematics refer to the study of what? And the answer is forces and movement. Kinetics is the study of forces, irrespective of the movement that they produce, or that the force produces, and kinematics is the study of movement, irrespective of the force that produced that movement. So when you put them together, you have a full understanding of how the movement occurred. Forces produce movement. So we separate them into two so that we can better understand the topic. But your answer there is D. Kinetics is the study of forces, kinematics is the study of movement, so D. Okay, so your next question was, which of the following best describes the anatomical position of the rectus femoris? They're quite lengthy answers, so I'm not going to read them all out, but the answer was the rectus femoris, which is your most superior and medial quadriceps muscle, is medial to the vastus lateralis, so it's relative to the vastus lateralis, it's positioned medially towards the midline of the body, but relative to the vastus lateralis, it is lateral, so it's in between the two, is what that sentence is saying. The rectus femoris is one of your knee extensors, but also functions as a hip flexor, and as I believe we've discussed before, you can actually palpate the tendon of your rectus femoris by finding the anterior superior iliac spine on the front of your pelvis, which is the most, we have obviously one each side. You have two lumpy protuberances on the front of your pelvis, some more lumpy than others. And if you find these two knobbly bits on the front of your pelvis, just above the belt line more or less, and move your fingers, if you move two fingers down about an inch and then flex your hip, you will be able to feel the tendon of the lateralis. The rectus femoris, what am I saying? And obviously all of those three muscles, along with the vastus intermedius, converge into one singular tendon, the quadriceps tendon, which inserts and attaches onto the tibial tuberosity on the front of the shin. Okay, your next question was, in which plane of motion does the majority of movement occur when performing a lunge? Your options were coronal, sagittal, frontal, and transverse. So I think I cut out there. Coronal, sagittal, frontal, and transverse, just in case I did cut out. The answer was, drum roll please. Someone do it. Go on. Someone at home do it with their fingers. Just drum roll with their fingers going. B, sagittal. So a lunging motion, or indeed a squatting motion, or any movement that involves flexion and extension of the ankles, knees and hips, is going to occur in the sagittal plane. Sagittal movements are primarily flexion extension movements. The coronal plane, if you're wondering, is just another term that's used for the frontal plane. Some people say coronal, some say frontal, doesn't really matter. Coronal is the more traditional term for the frontal plane, which separates the body anteriorly and posteriorly, back to front, and the transverse plane separates the body superiorly and inferiorly. So in the frontal/coronal plane we usually see abduction and adduction, and in the transverse plane we typically see rotation. There are exceptions to this. For example, if you stand up straight and rotate your foot internally and externally, so twist your foot inside and out, which involves rotating your whole leg. That is abduction and adduction of the foot, which is occurring in the transverse plane, so that's just one exception. But generally, frontal and coronal are abduction and adduction, sagittal flexion extension, and transverse internal external rotation. Okay, your next question was a mathematical one. It required you to perform a vertical jump where you exerted a force of 2,347 newtons for a duration of 0.9 seconds. So what magnitude of impulse was produced? The answer was D, 2,112.3 Newton seconds. You would simply multiply the force value 2,347 by the time value that we have, which is 0.9 seconds. So you're just multiplying those two values together. So your next question was a potentially tricky one. It was the same scenario, but we were asking how much momentum was produced, but you weren't given, oh sorry, I've got a creepy chair. You weren't given any additional information. The answer is D, 2,112.3 kilogram meters per second. So as you can see, that is the same as your answer for impulse. So impulse was 2,112.3 Newton seconds. Momentum was 2,112.3 kilogram meters per second, because impulse is equal to a change in momentum. So whatever force is applied over whatever duration of time will be equal to the velocity of the mass of the object that is moved. So impulse is equal to a change in momentum. So if you have impulse, you know that momentum will be the same value, just with a different unit of measure, and vice versa. So you've already seen the answer for the next question. Which of the following is an accurate definition for inertia? The answer was C. Inertia is an object's resistance to acceleration. It's not quite the same as mass, so B isn't correct. Mass refers to how much of something there is. If an object has mass, we're simply saying how much of it is there. Inertia is very subtly different. We're saying with inertia how much is this object's mass resisting movement. So the greater the mass, the greater the resistance to movement, because the inertia is increased. And interestingly, if we define inertia as an object's resistance to acceleration, momentum is a nice way of defining an object's resistance to deceleration, which is D here on this list. So your answer was nonetheless C. Okay, the next question was, which of the following is not one of Newton's laws of motion? Hopefully an easier one this. The answer was, you had to choose from the law of inertia, acceleration, gravity and reaction. And the answer was the law of gravity. That is not one of Newton's laws of motion. Not really much to say here. Yeah, I think we'll just move on. Just C was the answer. Your next question was, which of the following is the most accurate simplified definition for linear velocity? So is it the product of speed and direction? Is it constant unless an external force is present? Is it distance divided by time? Is it synonymous with momentum? The answer is, another drum roll quickly, A. If you were to define velocity in its simplest terms, you could say, well, it's just speed with direction, because it is a vector measurement. Remember, vector measurements have magnitude, or size in simpler terms, and direction. whereas speed is scalar. It just has magnitude. So other scalar measurements include time, mass, obviously speed, distance. These are all measurements in which we don't consider the direction in which something is moving. So velocity is speed, but with direction taken into consideration. If you attempted by C, velocity is displacement divided by time. Would have perhaps been another popular answer, but not quite right. Not distance. Distance divided by time is speed. Okay, your next question was, which of the following is the most accurate description of the work done when lifting and lowering a barbell? So we said in the example of a barbell curl, lifting the barbell and then lowering it. So what sort of work is done in those two phases, in the lifting phase and the lowering phase? Is it positive and negative, negative and positive, active and reactive, or reactive and active? The answer is positive and negative. So the concentric or lifting phase is where we perform positive work. So we perform work, or work is done onto the barbell because we are expending energy moving that barbell into a different position. However, when we lower the barbell back down again, we are not physically, it's not us that's actually physically lowering, it's gravity that's pulling it down, and we are simply controlling the speed, or the speed is not the right term to use, the rate of descent, the velocity at which the barbell is being lowered. So positive work is where we do work on the barbell, negative work is where the barbell does work on us. So that would be the concentric and eccentric phase respectively. Okay, so the next question asked you to select the most accurate definition for mechanical power. So is power able to produce movement and deformation? Does it result in a change in an object's velocity? Is it the product of all the forces acting on an object, or is it the amount of work done per unit of time? The answer is D. It is the amount of work done per unit of time. So power there are a number of different ways to calculate power, as we've previously discussed, but the more work you can do over a period of time will increase your power output. So for example, if let's say you are, let me try and think of a good example. Let's say you're performing a deadlift and you have someone next to you that's also performing a deadlift with the exact same amount of resistance that you're lifting. If you are able to shift that resistance up and down, so pick it up, lower it down, faster than the person next to you, you have done the same amount of work but over a shorter period of time, therefore you have produced more power. You're the more powerful of the two. So the next, not so much question, but the next task asked you to rearrange the gait cycle, or ask you to rearrange the features of the gait cycle that you were given into the correct order. And they are as follows. So just 1 point here, so you either get this right or wrong. Initial contact, so that's where the foot first comes into contact with the ground. It could either be a heel strike, a forefoot strike, a midfoot strike, toe strike, but initial contact. Flat foot, this is where we lower the foot onto the ground if it hasn't been already. So if we heel strike, as most of us do when we walk, the foot is in a neutral position. We then go into a controlled plantar flexion to lower the foot onto the ground. That is followed by mid-stance. This isn't all the phases of the gait cycle, I should say, but these are just some. Mid-stance follows on from that. This is the point where the body is balanced on the stance limb. The other limb, or the contralateral limb, is going through the swing phase, and it is the exact middle of the stance phase where the hip, knee and ankle are all vertically aligned. Heel off is directly after, well, more or less directly after we're back in double limb support, so the contralateral limb has come back into contact with the ground and has started a new gait cycle. The limb that we're currently looking at is now behind the body, so the hip is in extension and the heel is lifted off the ground. We then go into the swing phase, and obviously mid-swing precedes terminal swing. Mid-swing is the middle of the swing phase, terminal swing is the end of the swing phase. Okay, the next question asked you to spot the incorrect equations, and you can have 1 point for each one that you got correct. Are you ready? Very exciting, I imagine. Okay, there were 1, 2, 3, 4, 5, 6 that were incorrect, so 6 possible points available here. I do encourage you to, once you've done this quiz, to ring each other up and brag about your score to your friends in your cohort. Okay, so answer is impulse is not force divided by time. Of course it isn't. It's force multiplied by time. Acceleration obviously isn't going to be velocity multiplied by time. Acceleration, as is written in the bottom right hand corner there, is velocity divided by time. Velocity is not distance multiplied by time. It's displacement divided by time. Weight is your mass multiplied by the acceleration of gravity, which is 9.81, not 8.91. Bit of a tricky one, that. Velocity is also not distance divided by time. Again, it's displacement divided by time. And power is force multiplied by velocity, so not force multiplied by time. The correct equation for power is above the incorrect one we have here. Okay, so the next question asked you to spot the odd one out once again and basically complete a sentence. An unopposed force will cause an object to accelerate, an object to deform, an object to change its speed, an object to move, an object to change its velocity, and the odd one out is an object to change its speed. The others are all technically accurate. An unopposed force will cause an object to accelerate or deform because forces cause movement or acceleration, so A and B are correct, and also therefore if an object is accelerating it's moving, so therefore D is correct. And acceleration is the same as a change in an object's velocity, so therefore E is correct. So C is the odd one out because speed is scalar, and we use vector measurements to determine the movement of an object once the force is applied to it. Okay, the next one, bit of a potentially a trick one. Well, not a trick one, but potentially a tricky one for you. So the Achilles tendon inserts 5 centimeters from the ankle axis. If one calf muscle produces 3,000 newtons of force, how much torque is produced when you stand on your tippity-top tip toes? Is it A, 150 newton meters, B, 120,000 newton meters, C, 6,000 newton meters, or D, 300 newton meters? I'm hoping most of you either got A or D, but the correct answer is D. So you would have needed to convert centimeters into meters, so that would be 0.05. You would then multiply 3,000 by 0.05, which would give you 150 newton meters, but of course you have 2 legs, or presumably you do, therefore you would have to multiply that value by 2. If, however, you multiplied force by 5 and came out with 15,000 or 15,000 and then multiplied that by 2 to get 30,000, I would accept that as a correct answer as well, as long as the unit of measure was Newton centimeters and not Newton meters. But D is the answer. 300 Newton meters or 30,000 Newton centimeters. We like to work in meters because it's smaller numbers and math hurts our head. Okay, and finally then, holding a barbell in an isometric or static position with your elbow flexed at 90 degrees produces an external torque of minus 254 Newton meters. What, therefore, is the magnitude of the internal torque required by your elbow flexors to maintain the barbell in its position? The answer is A. If there is no movement occurring, if the barbell is in a fixed position, then the torque being produced by elbow flexors would have to equal the external torque being produced by the weight of the barbell. If your elbow flexors produced a torque greater than the torque of the barbell, then you would start to flex your elbow and lift the barbell. If, however, you lowered the barbell, then your muscles have to produce a torque slightly lower than, or well, I say slightly lower, it could be anything lower than 254 Newton meters. So overall in this equation, if you were to add these values together, you would get 0 Newton meters, and that's because there's no angular velocity occurring or angular acceleration. You're just holding the barbell in a fixed position. Okay, that's it. So tot up your answers, brag about them to your friends. Even if they're not on this course, just tell them. They'll have no idea what you're going on about, but why not? I was going to say apologies, but I suppose it's not really the right term. It's a shame that we weren't able to finish the module together, but I'm sure you'll do me proud, and keep up the good work, and I will see you for your upcoming assessment.